In the previous demonstration, Excel was used in the calculation of binomial probabilities where the actual binomial formulas were used. In this demonstration, I'm going to show you a simpler way to calculate the binomial probabilities using Excel's binomial distribution function. In the spreadsheet, I have reproduced the information used in the previous example. The task is to compute the probability of making basketball goals. Here is the situation. 6 shots will be taken. The probability of making any single shot is 30% or 0.3. Therefore, the probability of missing any single shot is 70% or 0.7. The question is, what is the probability of making 0 goals in 6 shots, 1 goal in 6 shots, 2 goals in 6 shots, etc.? The function Binomdist can be used to compute the probability of making a certain number of goals in a certain number of shots given the probability of making any single shot. In this case, the number of shots is 6. The function can also be used to compute the cumulative probability. In this example, 1 or fewer goals, 2 or fewer goals, 3 or fewer goals. Let's see how this works. In column A, you see the number of possible goals to be made given the number of shots taken, which is 6. Let's compute the probability of making 0 shots or 0 goals in 6 shots taken. First, we will click on the Formulas tab, click on More Functions, Statistical, and we'll click on Binomdist. And up comes the function arguments list. The first parameter is the number of successes, and in this particular case, it is 0. The second parameter is the number of trials, and in this particular case, it is 6, which will make the reference absolute by punching F4 to put $ around the row and column indicators. The next parameter it asks for is the probability of success on each trial, and that is 0.3. We will also set it to absolute reference. And then finally, it asks if we want to compute the cumulative probability, and in this particular case, we will say no by typing in false. And when I click OK, we will see the probability of making 0 goals in 6 shots. Next, we can simply copy this function to the other shots taken and compute the probability of making that particular number of shots for each of the occurrences. 1 shot or 1 goal in 6 shots, 2 goals in 6 shots, and so forth. Next, we'll compute the cumulative probability, and we will also use the Binomdist function, and it is exactly the same as we did in the first example. We'll specify the number of successes, the number of trials, set that to absolute, the probability of success, set that to absolute, and in terms of cumulative, we will indicate that this is true. So it will indicate that the cumulative probability of making 0, and of course there are no fewer shots, is 0.117. When we copy this down, we will see the cumulative probability as it goes from 0 to 6. So the probability of making 6 or fewer shots is 1, of making 5 or fewer shots is 0.999, and so forth. In the previous example, a chart was inserted to map the probabilities, and we'll do that in this particular case also. So we're going to go to Insert, and then we will highlight the probabilities that we're going to graph. We'll go to Column to insert a column chart, and here we have a column chart that maps or graphs the probabilities. Next, I'm going to change the horizontal axis identifiers so they will correspond with the number of successes in each trial. So here we go, and it puts 0 through 6 on the horizontal axis. Just as in the example, we're going to do away with the legend because it doesn't really add very much to the chart. And so you see, and if you compare this to the chart in the other example, it will be exactly the same. We can also, as they did in the previous example, show you how the chart will change if you change the probability of success. So, for example, if you had a 0.5 or 50% probability of success of making any one shot, then the distribution becomes symmetrical and looks like this. If you had someone who was a really good shooter and made 0.9 or 90% of all of his or her shots, then the distribution would look like this. Let's return it to 0.3, and we will see that distribution, and that's what I'll leave you with this example.